Hi everyone. So next we are going to see about the data that makes sense, right, in Unit 1. So the subject is data exploration, feature engineering and visualization with subject code 22AM502. Okay, right? So next we are going to see making sense of the data. So what are the different types of data that is going to be available in the data source? Okay, the data can be in a discrete format, it can be in a nominal format, it can be in a continuous format, and it can be an ordinal format. So what is discrete format? It has a discrete value. No, it is not going to be in a continuous form. That means it will take only counted values, not in a deciment values. Okay, like count of students in a class. So it is going to have a discrete, a fixed value, integer values. It's not going to have floating point values. Okay, what about nominal values? What does nominal represent? It represents qualitative information without any order. It's not going to have a 1, 2, 3, 4 like this ordering in the values. It's going to have a qualitative information without any order. That this is going to happen, that is going to happen next. It's not going to have any order of it. Like for example, let us take very good. I like the video very much. I like it to a moderate, and I'm liking it to a lesser likability. So like better, best, like that when it's not going to be ordered. Okay, so that those kind of ordering is called as ordinal. Without ordering it comes, then it's called as nominal values, like genders, like male and female, eye color, all these. Okay, continuous values. So when it's fixed values, continuous values are number within the range. You're going to give a target, and those values are going to come in the continuous format, like height, such as height. Okay, these are some types of data that are going to be available in your data sources. So what kind of analysis you're going to do with all these data? You're going to do some univariate analysis. Univariate with the single data. When you're going to do an analysis, you're going to do the presumptions and assumptions using one single column of a data set. Okay, there will be multiple data in a data set. Okay, in that you're going to take only one specific column and you're going to do the analysis. Then it is going to go and like you're going to do a bar chart on with that one single product. Okay, then it is called as univariate analysis. Okay, that uni means one. So it is other words. Your data has only one variable. Okay, so it has only one variable which can occur from the data, from the column of data. Okay, bivariate, you're going to take conclusions using two columns in a data set. Okay, when this is increasing, what happens to the when the height is increasing, what happens to the weight? How long he can walk? Okay, when the height is increasing, what is his parallel is weight? So how that is what you're going to do. That is a bivariate. The data of two variables. If you often want to measure the relationship that exhibits between these two categorical values. So bivariance can also allow to be performed numerical values or a combination of numerical. Using this as well as using this, you're going to predict the how long he can walk. Okay, this is called as bivariant. Multivariant, multiple columns you're going to take it for analysis for doing the conclusion. If this is going to be the height, this is going to be the weight, how long he can walk, how long he can sleep. So multivariant. Even bivariant can also be called it, but more than two comes under multivariant data, which has more than two variables and often want to measure the relationship that exhibits between these features. Okay, understood? So what is different types of analysis? The one more analysis called as numerical analysis. You're going to do numerical in the form of percentile. Okay, 25 percentile, 100 percentile. Okay, it's not percentage, it's going to be percentile. Or you're going to do a correlation matrix. Okay, using feature engineering, we are going to do the correlation analysis. Okay, those are called as numerical analysis. Okay, these are the different types like uni analysis, univariate, bivariate, multivariate, and so when you're talking about percentage, there is something called kurtosis. Okay, what is this kurtosis? Is nothing but a perfect binomial which comes. These are outliers with less number of outliers when it's performing a peak. Okay, a perfect binomial distribution that forms, that is called kurtosis. Okay, In that, we have three types of mesocritic, lithocritic, and lipocritic. Kurtosis is a measure of a tailness in the distribution. The tail, it's going to talk about how long this tail is going to be, the tailness, and how the outliers are going to be formed. These are going to be unwanted values. Okay, these values are the most wanted values. These values are going to be unwanted values. The tail are the taping ends or either side of the distribution. They represent the probability or the frequency of values that are extremely high or low compared to the mean. Okay, this is how the different types of kurtosis are going to be mesocritic, lithocritic, and lipocritic. So mesocritic is nothing but which is going to be a perfect binomial distribution. Okay, which is going to have k is equal to 3. Okay, when k is equal to 0, then it is called as a normal distribution curve, which is called lipocritic. The distribution has a static similar to that of a normal distribution, meaning that the extreme value characteristics of the distribution is similar to the normal distribution. The mesocritic distribution is a medium-tailed. It doesn't have a big tail. It has a medium-tailed curve. So outliers will not be formed when you are using this kind of kurtosis. Normal distribution has a kurtosis of level 3. There are 3. So when it's 3, it is said to be as mesocritic. So lipocritic is nothing but little higher. The lipocritic is a crucial one, okay, a peak one, okay, which is not normal. It has a greater kurtosis, okay. That means it is greater than 0. This is K6T or K is equal to 0. Keep it this way. K is greater than 0. So then it is called as lipocritic. Okay, a skinny or a narrow makes some shape that is being made. And lithocritic is nothing but there is no hump at all, there is no peak at all. Okay, but lot of outliers are there. Okay, which is less than 0. Okay, can you understand? So this is about kurtosis. Okay, thank you.